Today's lesson is evaluating the nth roots and using rational exponents. And the first thing we need to talk about are some vocabulary and the properties that we're going to use. So the first thing is the vocabulary. So one thing to keep in mind is that the nth root of a for an integer n greater than 1 if b to the n equals a, the b is an nth root of a. And then the second vocabulary to keep in mind is the index of a radical. The index of a radical is the nth root, where the nth root is of a written as the nth root of a, where n is the index. And what I normally do is I think of it where the index is within the check mark of your radical sign. Now we have some properties to keep in mind. And so I'm going to go ahead and show those here. So if n is an even integer, 1 point is that a is less than 0, you'll have no real nth roots. The next one is when a is equal to 0, you will have 1 real nth root. And for instance, that's going to be the nth root of 0 equals 0. And then the third one is if a is greater than 0, you will have 2 real nth roots. And you're just going to look at plus or minus the nth root of a, which is the same as saying plus or minus a to the 1 over n power. So now we're going to look at if the n is odd. If n is an odd integer, again we have points. We have a is less than 0, you have 1 real. And again, this is going to be n square root a, which is the same as saying a to the 1 over n power. If a equals 0, you have 1 real. And this time we have n to the 0, the nth root of 0 is 0. And then again, when a is greater than 0, we still have 1 real. And we have n, the nth root of a, again, a to the 1 over n power. So those are the points or the properties to look at when we're evaluating the nth roots. Now, we are going to look at a couple. We're going to find the nth roots. So the first one I want to do, it gives me n equals 6, and it gives me A equals 64. So what I'm going to do is notice first that my n is greater than 0. So that lets me know I'm going to have two real nth roots. The next thing I want to do is I want to say, okay, well, if I write it in this form, I have a plus or minus the 6th root of 64, which you can rewrite as the plus or minus 64 to the 1/6 power. And so now what you do is you actually find the number. You want to solve this, and it's going to give you a plus or minus 2. And so your 2 is your answer when we're looking at the 6th root of 64. And again, it's a plus or minus because every even number is going to have two real nth roots if it's greater than 0. Now, the second one we want to work says n equals 5 and a equals a negative 32. The first thing I want to see is the fact that my odd, well, this is 60. I'm going to see this, 5 is odd. So I'm going to have no more than one real answer. And then the next thing I want to do is look at a negative 32. Well, a negative 32 is less than 0, so again I have one real answer. Alright, so because it's odd and less than 0, I have one real answer. Over here, it should have been that 64 is greater than 0 and that 6 is an even number. So that's where we get the two real nth roots. Coming back over here, I want to go ahead and write this. Remember, the n goes in my check mark. So I can say the 5th root of a negative 32. Or I can say a negative 32 to the 1/5 power. And that is going to give me just a negative 2. And so with both of these, an even and an odd, you can see how it will be good to remember the points that they give you up here when it's an even integer and when it's an odd integer. The next concept we want to look at today is the rational exponents. Now there are two properties, and the two properties are a to the m over n can be rewritten as a to the 1m times to the m power, which can also be written as n the nth root of a to the m power. And the second is a to the negative m over n power, which again we know because it's a negative exponent, that means 1 over a to the m over n power, which we can rewrite as 1 over a to the 1n m power, which is also 1 over the nth root of a to the m power. And this one is when a does not equal 0. So now what we want to do is we want to go ahead and solve a couple. So the first one, and I've got rational and I've got radical. So rational first. Of the first one. The rational says 9 to the 5 halves. can rewrite that as 9 to the 1/2 to the 5th power, which gives me 9 to the 1/2 power gives me 3 to the 5th power, which gives me 243. Now for the radical form, again I have 9 to the 5/2 power. This time I'm going to rewrite it as the square root of 9 to the 5th power. So the square root of 9 gives me 3 to the 5th, which again gives me 243. What you've just done, or what you've seen done, is the rational, which is this top part, this part of it right here, and then the radical was this part, the second part of a to the m over n power. Now, and this is, of course, the property of exponent, positive exponent. So the second example is 27 to the negative 2/3 power. So again, I want to rewrite, and I can say 27 to the 1/3 power squared. I'm sorry. I need to get rid of my negative first. So 1 over 27 to the negative 2/3 power. Now I can rewrite it as 1 over 27 to the 1/3 squared, which will give me 1 over 3 squared, which will get me 1 over 9. So again, I'm going to look at the radical part of it now. 27 to the negative 2/3 power. The first thing I want to do is I'm going to write it, to get rid of my negative, I'm going to say 1 over 27 to the 2/3. But this time I'm going to write it as 1 over the cube root of 27 squared. The cube root of 27 is 3. So 3 squared, and again it gives you 9. So you have just seen how to use the rational form to use rational exponents to solve for them, or the radical form. You can choose either method. The last concept that we want to talk about today is solving equations using nth roots. And so I went ahead and put my 2 equations that I want to solve on the board. And so we're going to work on A first. Alright, A shows a negative 2x to the 6th equals a negative 1,458. When we are solving, we want to get x by itself. And so the first thing we need to do is go ahead and divide by a negative 2. So I'm going to divide both sides by a negative 2, which gives me x to the 6th, which is equal to 729. Alright, again, all we did was we divided by 2. Because 6 is an even exponent, we know when we do the root, again, the root cancels out the power. That means we're going to have a plus or minus square root of 729, because this 6th root cancels out 6. Alright, all we did was we found the 6th root. Now, x is going to be equal to a plus or minus, I'm sorry, I forgot my 6 up there. We need to know what number times what number times what number times itself 6 times equals 729. If you have your calculator, you can do that quickly. We can say 3 times 3 gives us 9. times 3 gives us 27. 27 times 3 should give us 81. So right now I've got 1, 2, 3, 4. 81 times 3, which would be 5, gives me, that is 243. And then 243 times 3, which is 6, would give me 729. So therefore my x is a plus or minus 3. So the answer to A, a negative 2 x to the 6th power equals a negative 1,458, your x is going to be a plus or minus 3. So now what we're going to do is we're going to come over and work our B equation, which is x plus 2, all of that to the 5th power equals 35. So for this one, the first thing we have to do is get rid of our power. So in order to do that, we have to say the 5th root of x plus 2 to the 5th power equals the 5th root of 35. Because 5 is odd, it is only the answer that we're given. So there's no plus or minus. So this 5th root cancels out the 5th power. So I have x plus 2 is equal to the 5th root of 35. Now again, we want to solve for x, so I'm going to say x equals, I have a positive 2 right now, but to get it to the other side of the equal sign, I have to change the operation, which gives me a negative 2 plus the 5th root of 35. And if you have your calculator, you can go ahead and plug that into your calculator to find your answer. And the answer would be approximately 0.04. But if you don't have your calculator, I would be fine with this negative 2 plus or minus the 5th root of 35.